So part F is asking whether or not the rate at which Joe Exotic hires new employees is increasing or decreasing at t equals 0. And just the way this is worded, it's a little bit challenging. So we need to really kind of focus on what function are we analyzing and what function are we seeing whether or not it's increasing or decreasing. And that function that we're focusing on is the function that represents the rate at which Joe Exotic hires new employees. And we were given in part E that the rate at which he hires new employees is given by the differential equation dy dt is equal to 1 minus y e to the 2t. So what this question is asking is it's really saying is dy dt, is that increasing or decreasing at t equals 0. And anytime we analyze whether or not a function is increasing or decreasing, we need to look at its derivative. So this question is actually asking us to calculate and analyze the second derivative of dy dt. Okay, so we need to take the derivative d dt of the right-hand side of this product, 1 minus y times e to the 2t. And there is a lot going on in that derivative, so I'm going to take some time to break up all of these steps. So notice that this is a product, right? We have our first function and then our second function, so we're going to need to utilize the product rule. So when we take the derivative, we'll leave our first function alone, 1 minus y, and then we need to take the derivative of our second function. We will then add to that our second function, e to the 2t, times the derivative d dt 1 minus y of our first function. Okay, so in calculating this, our 1 minus y will stay the same. The derivative of e to the 2t using chain rule is 2e to the 2t. Our e to the 2t will stay the same. And then I'm really going to break up this derivative to kind of see what all is happening. So I'm actually going to jump over to the side here and focus on ddt of the quantity 1 minus y. Notice that that can be rewritten as ddt of 1 minus ddt of y. The derivative of a constant is just 0, right? So this guy will become 0, and then we're left with negative dy dt. And so I'm going to rewrite that just to make my life a little bit easier as negative 1 times dy dt. Okay, so then I get to go ahead and put that back into my work over here. So we just found that ddt of the quantity 1 minus y is actually equal to negative 1 times dy dt. So this is our second derivative, right? But what's interesting is that it's in terms of a differential equation. So we actually need to go ahead and substitute that value in, or that expression in. We were told that dy dt is the product of 1 minus y and e to the 2t. So we need to go ahead and make that substitution in order to write the second derivative in terms of y and t, not in terms of the derivative. So our final answer for the second derivative of dy dt, oops, and I just realized that I missed a squared up here in this green line. Our second derivative of dy dt is then going to be 1 minus y, 2e to the 2t plus e to the 2t times negative 1 times dy dt, which again we were given in the last question, and that is 1 minus y e to the 2t. So we have our derivative of dy dt, and in order to figure out if this is increasing or decreasing at time equals 0, we're going to need to go ahead and plug that information in. We were also given in part E that when t equals 0, y equals 3. So we're going to go ahead and look at our second derivative. Whoops. Our second derivative at the point 0, 3. And you need to, on the AP exam, express that this is what you're doing, right? That you're going to go ahead and look at that function and evaluate it at this point. So we'll go ahead and plug this in. We get y minus 3 times 2e to the 2 times 0. In this next step, I'm going to go ahead, actually I'll just leave it as it is. I was maybe going to distribute that negative, but I don't want to get myself confused. So we'll have plus e to the 2 times 0 times negative 1 times 1 minus 3e to the 2 times 0. We want to see what this value is. Is it positive? Is it negative? So we'll go ahead and clean this up. This becomes negative 2 times 2 plus 1 times negative 1 times negative 2 times 1. And we end up with a negative 4 here, plus 1 times negative 1 is negative 1 times negative 2 is positive 2 times another positive 1 is positive 2. So negative 4 plus 2 is then equal to negative 2. And we need to have a conversation about what this means, okay? So this work here in the pink, this has told us that at t equals 0, the second derivative is equal to negative 2, which means that dy dt is decreasing because negative 2 is less than 0. So a lot kind of went on in this problem, right? That was a pretty intense derivative to calculate. And before I end this video, I want to talk about where points came from. So modeling kind of some AP scoring guides, you got 2 points. There were 2 points up for grabs in that calculation of the derivative. Okay, so you got 2 points here to kind of be allocated in a variety of different ways, right? There's a lot happening in that derivative. We had to recognize product rule, chain rule, and implicit differentiation. Okay, so 2 points up for grabs for getting the correct derivative, and then 1 point for this analysis saying that, okay, once you plug in t equals 0, you're getting something that is negative, and that means you have your function is decreasing. So another point here for your answer.